Guys, I'm Ethan with Chino Math, and today we're going to be solving some questions for the upcoming test in Mr. Rhea's Pre-Calculus and Trigonometry Honors class. So we'll be going over some questions that are commonly missed to get ready for the test. So here we go. Okay, so for this question, we're asked to find the function of the quadratic equation given the vertex and also the point on the graph. So given the vertex, he wants it in vertex form. So with the vertex, you're able to put the quadratic in vertex form. So the vertex form of a quadratic is y equals a times x minus h squared plus k, where a is the stretch or compression, h is the horizontal shift, and then k is the vertical shift. And remember, for the horizontal shift, always use tillner, so positive left, negative right. So with this case, given the vertex, we can put it in vertex form. So we have y equals a times x value is 2, so minus 2, squared, that's 3. And so with this one, we have a point now, so we can solve for a to find the stretch or compression. So the y value is 6, so 6 equals a times x is 7, 7 minus 2 squared plus 3, subtract 3, to solve for a. So 3 equals a times 7 minus 2 squared, so 7 minus 2 is 5, 5 squared is 25. You have a equals 3 over 25, which is a compression, so that will make the graph really large and long. So then with that, you can put it into the new equation, which you have y equals a is equal to 3 over 25, 3 over 25, x minus 2 squared plus 3. And that's your function. Okay, so in this case, the question is to find the polynomial function given these zeros, 2, negative 3, and 1 minus 2i. And first of all, you should already see that you have the 1 minus 2i, and those come in conjugate pairs. So you have 1 minus 2i, and then you also have 1 plus 2i. So you're asked to find the polynomial function. So these are the zeros. So just set these zeros equal to x, because they came from originally from the linear factors. So you have x minus 2, you have x plus 3, and then with these ones, you have x minus 1 minus 2i, and then you have x minus 1 plus 2i. And then with this one, remember I always comes from a real number equation, in this case quadratic, so you can multiply these together and you should get a quadratic with real numbers. So you just have to multiply this out. So you have x squared minus x plus 2x times 2i is plus 2xi, and then you have negative x, and then 1, and then minus 2i, squared. And you need to know your I rules. So with I squared is equal to negative 1. So automatically this turns into plus 4, and that can go away. So then you just have to combine like terms. So you have x squared. And then luckily in this case, in most cases with I, they'll usually add 0. So you have plus 2xi, that goes away with minus 2xi. And then you have plus 2i and minus 2i. So you have a negative x and a negative x is minus 2x. And then you have a 1 plus 4, which is 5. So that would be your quadratic that came from these factors, these two right here. And then, so once you have this, you can then multiply by these. First of all, we'll multiply these. So x squared plus 3x minus 2x, so plus x. So then you have this quadratic that came from these two, and you're going to multiply that by this that got over here from the i's. So x squared minus 2x plus 5. Okay, so then we're gonna combine like terms. So nothing goes with x to the fourth, so we already have x to the fourth. And x cubed makes minus x cubed, and then you have 5. And then we have 5x, and then we have 12x, which is 17x. Minus 30. Oh, and don't forget to put f of x. He will mark you down if you don't put f of x and he asks for a function. So there's your equation that you got from given these zeros. Okay, so the question here is to find all the possible zeros that go into this function f of x equals x cubed plus 4x squared minus 25x minus 28. So what you can do is with an odd numbered power, you can look to see if you can factor by grouping, which you would do this and then see what the factors are of each number. But in this case, it wouldn't work because you could pull out an x squared here and then you'd have x plus 4, but you can't pull anything out of 25 and 28, so that wouldn't work. So in this case, you would just go straight to synthetic division, where you can try to do the p's and q's things to find all the possible rational zeros. But for me, I just like to choose a number and start, so we can fill out the 1, since there's a leading coefficient 1, and then 4, and then negative 25, and then negative 28, and use your remainder. And if you get a 0 here, that's a factor. And then once you get a 0 here, you can take this and then factor that again if you need to find all the possible zeros. So to start off, what I like to do is I look at these first two numbers and see what goes into this and what goes into this. And so you see 28 and you think, let's see, 2, 1, 2, 4, and 7, and 28 itself. So I'm just going to say, or plus or minus, so I'm going to say just go with 1. So 1 times 1 is 1, it's 5. 5 times 1, 5. Negative 25 plus 5 is negative 20. Negative 20 times 1 is negative 20. And you see that doesn't work because negative 28 minus 20 is a large number. But honestly, keep this point, because once you get the x value and then you get a value out here, that's actually a point on the graph that you can use to graph the function. So it's not totally, you shouldn't totally disregard it, but in this case, just start over again. So I'll try, let's see if 4 works. So you see that we came out with a 0 here. So one of the possible factors is 4. So x equals 4. So to put it into factor form, you do x minus 4. But now you have x squared plus 8x plus 7, which is the number that comes out from the synthetic division. And it's always 1 power less than the one you originally started with. So the leading coefficient for this one is 1, and then it's x squared, and then 8x, and then 7. So you have a quadratic function which you can easily factor here, hopefully. So you see what number multiplies to 7 and adds to 8? 7 and 1. So you have these factors, x plus 7, x plus 1, and don't forget about the 4 that you had up here, where you got a 0. So you would have x minus 4, because x equals 4 here. And then, so these are all your factors, and then to find the zeros, all you have to do is set each individual factor equal to 0. So x plus 7 equal to 0, x equals negative 7, and then x plus 1 equal to 0, so x equals negative 1, and then x minus 4 equals 0, so x equals 4. And those are all your possible zeros of the function, or rational zeros of the function. And then you should see, So the degree is a third degree, so you should have 3 zeros, and if not, one of them could possibly be a double root. So you have the quadratic kind of thing going, where it doesn't cross the x-axis, it just bounces. But in this case, we do have 3 factors, which matches up with the third degree.